Hello, students. So, first, I would like to say thank you for visiting my channel. So, my channel is dedicated for those who are interested in learning chemistry. Um, so today's topic we are going to discuss about the USNCO questions, but this is from the 2021 paper. So it's a little bit late actually, but I hope this can still be a good source of learning. So, let's start from question 1. Okay, let's see question 1. So, at 120 degrees Celsius and 1 atm of pressure, 1 liter of methane CH4 reacts completely with excess oxygen to form carbon dioxide and water. What volume of the two products are produced at this pressure and temperature? So in this case, the first thing that you have to do is write the reaction. So here's the reaction. CH4 plus O2 produces CO2 and H2O. And then after that, it is important to balance the equation by putting the correct coefficients. So those are the coefficients 1, 2, 1, and 2. And then next is finding the volume of CO2 and H2O. So for this purpose, so please remember that mole ratio follows coefficients ratio. And then if you pay attention on the phase here, so both are in gaseous phase. So by assuming that they are ideal gases, we can say that the volume ratio follows coefficients ratio. So let's solve this. So first compare between CH4 and CO2. Pay attention that they have the same coefficient. So this means they will have the same volume. And then next, for H2O, the coefficient of H2O is twice of the coefficient of methane, so the volume will also be like that. So given that CH4, the volume is 1 liter, so we can say that the volume of H2O is 2 liters, while the volume of CO2 is 1 liter. So the answer is A. Okay, so question 1 is relatively easy. So let's proceed to question 2. So polypropylene is made by polymerizing propene. And then how many molecules of propene must be polymerized to make 3.5 grams of polymers? So first, the correlation that can be applied to solve this is mass equals moles times mR. So if you still remember what mR is, so mR is the relative molecular mass. So in this question, the value is given there, 42.1. So by substituting their values, we'll get 3.5 grams equals N times 42.1 grams per mole. So by doing simple mathematics analysis, we can get the N value, which is equal to 0.083 something. Well, you can use calculator. Unfortunately, the question asks about the number of molecules. So we need to, well, do a little more analysis here. So let's see. Finding the number of molecules, we can find the number of molecules by applying this correlation, x equals n times L. So L is the Avogadro constant. The value is 6.02 times 10 to the power of 23. So basically we have got the n value, which is 0.0830 something, and then multiplied by Avogadro constant. So, well, using calculator you can get this value, 5.01 times 10 to the power of 22 molecules. So the answer is B. And then, well, I hope my explanation is clear enough. So we can continue to question 3. An organic compound contains only carbon, hydrogen, nitrogen, and oxygen. So it is 61.7% of carbon, 4% hydrogen, 16% nitrogen by mass. So the percentages here are percent mass. And then the question is, what is its empirical formula? So to answer this question, it is safe to say that the mass of compound is 100 gram. Well, this is our assumption. So by assuming the mass equals 100 grams, then the mass of carbon is 61.7 grams, and then the mass of hydrogen is 4.03 grams. So basically we just replace the percentages here with the mass in grams. So the mass of nitrogen equals 16 grams. So if we add them together, the result is not 100 grams. So it is clear because here there is oxygen, which its composition is not known yet. But of course this is simple addition. So the remainder is the mass of oxygen, which is 18.26 grams. So next, after we find out the masses of the components, to find the empirical formula, we have to find the mole ratio of the components, or mole ratio of the elements. So let's recall the masses that we have obtained. So to get the mole, we have to divide these values with the AR value. So AR stands for the average atomic mass. Its value can be obtained at the periodic table. So here are their values. C is 12, H is 1, nitrogen 14, and then oxygen is 16. So this is the result that I got, 5.14, and then 4.02, 1.14, and so on. So however, these numbers are not good looking, so we have to simplify them by dividing them with the smallest number. So dividing the numbers, we can get these values, 4.5, 3.5, 1, and 1. But this is still not simplified yet. So we have to multiply by 2 so that we can get the ratio of 9 over 7 over 2 and then over 2. So until here, I hope you have no problem. Okay, so the empirical formula of this compound is C9H7N2NO2. So the answer is B. Okay, so let's proceed to question number 4. So there are two solutions here. So first is calcium bromide, 100 milliliters, half m, and then natrium bromide, 50 milliliters 1 m. So what is the concentration of the bromide ion in the resulting solution? So please remember that mole equals concentration times volume here. So well, since there are two substances here, so for calcium bromide, the mole is 50 millimoles. Well, this is from 100 times 0.5. And then for the other substance, sodium bromide, so the number of moles is the same actually, 50 times 1, so produces the same number. However, the question is to find the concentration of the bromide ions. So we have to convert these moles into bromide ions. So first, for calcium bromides, since here the valence is 2, so if there are 50 millimoles, then the number of bromide ions will be 100 millimoles. Yeah, which means we multiply by 2. And then for sodium bromide, since the number of bromide ions is 1, so the number of bromide ions is equal to the amount of the salt. And then if we add them together, we will get 150 millimoles. And then let's see the volume as well. So the total volume is 100 plus 50. So the result is 150 milliliters. So the concentration of the bromide ions is equal to 150 millimoles over 150 milliliters. So eventually this equals to 1 mole over liters. So the answer is D. So next we proceed to question 5. So 1 grams of hydrated potassium carbonate is heated to 250 degrees of Celsius to give 0.836 anhydrous potassium carbonate. So what is the value of N? So first we need to write the chemical reaction that happens when hydrated potassium carbonate is heated. So this is the chemical equation as you see. So it produces water in gaseous form, or we can say water vapor. So since the phase is gas, so water vapor will escape from the container. So this is the reason why the mass is decreasing. So next is to calculate the mass of water vapor produced. So this can be obtained by subtracting the two masses before and after the experiment. So this means 1 minus 0.836, and then the result is 0.164 grams. So this is the mass of water vapor. However, the more valuable information is to find the moles. So again, we can use this correlation, and then the MR value of water is 18. So we can get the mole of water vapor equals to, I convert the number, I convert the mass from grams to milligrams to make the calculation simpler. So the mole of water vapor is 9.11. So next we apply the same thing for potassium carbonate, but first before that we need to find the MR value. So if we take a look, there are 2 potassium atoms, so 2 times 39, and then 12 is from carbon, and this is oxygen. There are 3 oxygen atoms. So if we calculate this, we will get 138 grams over mole. And then applying the same correlation to find the number of moles. So the moles is equal to, this one I convert to milligrams as well. So 836 divided by 138. The result is 6.06 millimoles. Okay, so after this, we need to find the mole ratio. So mole ratio is 6.06 over 9.11. So the result approximately equals to 2 over 3. So, but in the option, there's no such answer. So we can say that n equals 1.5 or 1.5. So the answer is C. Okay. So the last question for today is question 6. The question is a little bit long. So the concentration of an aqueous solution of a non-volatile monoprotic acid is measured first by freezing point depression and then by boiling point elevation. The solution is found to be 0.93 m by freezing point depression and 0.82 m by boiling point elevation. Which is the best explanation for this inconsistency? So first, let's see the dissociation reaction of a monoprotic acid can be written like this. So as we can see, it produces H plus ion, and then it produces the other anion as well. So this is the correlation for boiling point elevation and freezing point depression. So from the question, it is said that from the boiling point calculation, so the molality is 0.82, and then from freezing point calculation, the obtained value is 0.93. So, well, there's little inconsistency here. But anyhow, if you look at the reaction, so this reaction happens at both way. I mean that this is an equilibrium reaction. So equilibrium reaction the composition can change. So in this case, the composition change because of the temperature. So as we can see, the equilibrium shifts to the left as T increases. So as you can see, this is boiling point, this is freezing point. So the value is greater when temperature decreases. So the equilibrium shifts to the left as T increases. So it favors to the left side as T increases. So this means when temperature increases, the reaction shifts to the endothermic reaction, which is to the left. So this means the main reaction, which is going to the right, is an exothermic reaction. So I hope you can understand my explanation here. So the answer is A. Okay, so I think that's the explanation. So for today, I only discuss about 6. I only explained 6 questions. So that's all for today. So thank you very much and see you next again.